So we want to take the partial derivative of e with respect to x. So we start off with e equals to 1 plus r over x to the power of x minus 1. Here we have an x up here and an x over here, so we can't use the product rule, and we can't use the quotient rule, and we can't use the power rule, so we're going to have to do something else. So what we're going to do is whenever you see like the x in the exponent and x in the bottom part, in the base, most likely you're going to have to take the ln of both sides. So what we're going to do first, before we take the ln of both sides, is we're going to move this 1 to the other side. So we have e plus 1 equals to 1 plus r over x to the power of x, right? And so what did I do on both sides? What I did was I add 1 to both sides, okay? And then after, what happens next is we can take the ln of both sides. So we're going to take the ln of both sides. So we have ln of e plus 1 equals to ln of 1 plus r over x to the power of x, right? And what we did there, we took the ln of both sides, okay? And then now we can use our log rules. So what the log rules is we have ln of a to the power of b. This is b ln a. And so we also have, what else do we have for the log rules? We have ln of a times b. This is ln of a plus ln of b. And the other ln or logarithmic rule is ln of a over b equals to ln of a subtract ln of b, right? So the one we're going to use is this one right here, okay? So that rule right here is, this is the exponent b, like this is the b and this is the a. So putting that together, we have x ln of 1 plus r over x. That's what we have there. And so this is by log rules. And then what do we have next? So now we have something where we can take the derivative of both sides, and we can use product rule, we can use, what other rules do we have? I think that's it. So let's do that. If we take so actually I'm going to write something here. The next step we're going to do is take the derivative, then take derivative of both sides with respect to x. Okay, so we're going to take the derivative with respect to x. So we're doing partial derivatives here. And so let's do that. We have, if we take the ln of this part, the left-hand side, ln of the derivative of, the derivative of ln of something, a function of x, will always be the derivative of the inside over 1 over the inside. So now we have 1 derivative of the inside, so it's e, partial derivative of e with respect to x, right? Plus the derivative of 1 with respect to x is just 0, right? And then all over the derivative, not the derivative, just whatever's inside. So whatever's inside is e plus 1, right? And then the right side, we're going to have to use the product rule. Okay, so right hand side, we're going to have to use the product rule. And for this, I'm actually going to write this a little bit smaller just so that we have room. So I'm going to write this as partial derivative of e with respect to x plus 0 all over e plus 1. Actually, I don't even need to do that. And this is equal to, now we're going to do the derivative of the right hand side. So the right hand side, we have two things. Let's call it like f and g, right? So we're going to use the product rule here. And the product rule is we're going to do derivative of the first times the second plus the derivative of the second times the first. So it would be like derivative of the first times the second plus the derivative of the second times the first. So that's the product rule here. So that's product rule. And so let's fill it out. What's the derivative of the first one? X. So that one is just 1, right? Times times g. So g is ln of 1 plus, I'm going to just write this a little bit smaller so that we have room. 1 times ln of 1 plus r over x plus g, derivative of the second one, times f. So what's the derivative of the second one? Derivative of g is, so we have a ln, so it's something, the derivative of the inside over the inside, right? So 1 plus r over x, and then the derivative of this inside part, and what is that inside part? Well, derivative of 1 is 0, plus the derivative of r over x. So the derivative of r over x, so think about this like, let's use a different color. This thing, think of r as a constant, right? And it's just 1 over x. So it's like r over x. And so you can kind of think of it like r to the x minus 1. And now we can use the product rule. If we take the derivative of this thing, it's just going to be negative 1 r and then x to the negative 2. That's the product rule, right? You bring this negative 1 down, and that's how I got the negative 1 here. And then you have the r, which is a constant, and then you subtract 1 from that exponent n, right? N minus 1. So it's minus 1 becomes minus 2, and that's how we get the derivative. Okay? So then that would be, if you write it in terms of a fraction, how would that look like? So this would look like negative r, sorry, I'm going to write this again, negative r over x to the power of 2, right? Because that's x minus 2, okay? And so that's what we have there. And let's just simplify it a little bit more. So I'm going to just, this is f. I'm just going to write this. This part is this part. This part is this part. Just so you're g prime. I'm not even done that part. This is g prime here. And then what is f? F is, the last part was x. So we have to multiply this by x right here. So that's the product rule. Okay. So now we just have to simplify everything. Now, let's simplify everything. And so I'm going to rewrite this as e sub x. Okay, so just how they wrote it in the question. So it's e sub x, right? And over e plus 1 equals to ln of 1 plus r over x plus, I'm going to simplify this a little bit. So we have this plus, actually I'm going to get rid of it and I'm going to say minus. And the reason why it's minus is because we have that minus sign here. So I'm going to say minus r, okay, over, actually it's rx because there's an x here, rx over x squared times 1 plus r over x, okay? So this x comes from here, this x squared is here, so it's in the denominator, and then this is the denominator there, okay? And so now we can cancel some stuff out. This x will cancel out with this, so then we have just the x at the bottom. And then I can simplify it a little bit more. So let's just do that. So here we have e sub x. So that's the derivative with respect to x over e plus 1 equals to ln of 1 plus r over x. So everything stays the same except for this last part. And I'm going to rewrite it as minus r over x and then something in here. So we have a fraction, but I'm going to try to change this fraction so that it's not like a mixed fraction. I'm going to make it a fraction. So we have 1 minus r over x. So that's just x plus r over x if I put it into one fraction, right? And so now we can see that, okay, things will cancel out. So this cancels out with this, right? And so here we have e sub x over e plus 1 equals to ln of 1 plus r over x minus r over x plus r. So it's kind of starting to look like what we wanted to find, right? The only thing is here, now we have this e plus 1. So now we're going to multiply both sides by e plus 1. So we have e sub x equals to ln of 1 plus r over x minus r over x plus r, right? And we want to multiply this by e plus 1. Actually, I think they wrote it in a different way. I think they wrote the e plus 1 first, but it's the exact same thing. Yeah, they wrote the e plus 1 first. So, I mean, we could just swap it around, switch this around, right? That's all. So, I'm going to actually rewrite it just so that it looks exactly like the answer that we want. So we have, here we have, multiplying both sides, we have e plus 1 times ln of 1 plus r over x minus r over x plus r. That's the answer.